Okay, here we are again. Yeah, again. Thank you. So it seems to work now. That's a good thing. So I will be talking about AI-generated music detection, and so how we detect AI-generated content. I will first present what I'm talking about with AI-generated music and explain why it's a problem, and then go to how to detect it. Okay, so maybe a very short word about myself and my team. So I'm Romain Hennequin from Deezer Research. Deezer Research is a team of research scientists and research engineer and PhD students working. So yeah, it's there that I realize that my smile is totally frozen and that I should change this picture. Anyway, we are working on various fields: music information retrieval, audio signal processing, natural language processing, recommender systems. It may seem very obscure to you, but be aware that this talk will be very technical with a lot of equations. No, I'm kidding. Just stay, don't leave. Anyway. Okay, so as I said, a short introduction of generative AI and all the fuss about it, the impact on nowadays music industry, and how we detect it. So first, let me remind you that generating music with computer is actually not a new thing. And like actually the very first music composed by a computer was date back from 1957. Was called Iliac Suite, was composed in Urbana-Champaign, I guess. So it's actually a very, very old topic to generate music with a computer. Then afterward, we've been able to generate sounds from symbolic representation. And as soon as the early 20s, there were like general audience tools such as Songsmith that would help like the general consumer to compose music. But today I will talk about two new capabilities of AI that were released quite recently. So the first one is the ability for modern generative AI model to reproduce the voice of famous artists. So here, for instance, oh, come on. Sorry, that's not my computer. Will it play? Hey, play. So here you can, come on. That's gonna be long. Anyway, here, so you can see that the vocal of Pharrell Williams was replaced by a voice that was very similar to the one of Michael Jackson through a vocal cloning system. And another recent capability of AI in music, you're all aware of it, it's the large language models that were applied for music generation, and now from like a very simple prompt, such as a dark funk song about going to California, you can generate with one click a song that sounds quite realistic. Come on. Welcome to California. Groove is your guide. Electric streets where the secrets hide in California. Yeah, you dance with your fear, but the funk is divine. It's crystal clear. Good. It's crystal clear. So this was generated by Suno with this prompt. So new tools, fantastic. But what could go wrong? So there are tons of things that could go wrong. I will present first from a DSP perspective because I'm from Deezer. So what could go wrong? So typically you can use Suno or Audio, which does basically the same. You will generate some song. And as you can see, you are someone with a laptop and a hoodie, so you must be a hacker or someone very bad. So what will you do? You will deliver it to Deezer. Okay, so what does it mean? Now, anyone any hacker with a black hoodie can generate realistic music massively, like in one click you have one song. So for a few bucks, very, very cheap, you can generate thousands of tracks and deliver it to providers. So does it happen? Obviously it happened. So for instance, this is a track that was generated on Suno by some user, and you can see that we have the exact same track on Deezer. But you may say, oh, it's only Deezer problem because they are very bad at detecting AI. But if you look at competition, like everyone is affected, so everyone has some Suno content. So just little parenthesis, how do we know, how do we detect that we detected that this song was in Deezer? Actually, we have a very robust audio fingerprinting technology, which is called Radar, and which makes it possible, if you download a song from Suno, to identify in our catalog that it's here or not. Anyway, end of the parenthesis. So what could go wrong? Deliver to Deezer. What for? Hey, make money. So one of the possible usage of realistic generated content will be to do stream fraud. So basically, you can deliver your content. So you don't need it to be realistic, but if it's realistic, it's probably more convincing for detection system. You can generate your music, realistic music, deliver it to Deezer, then you create fake accounts or you steal accounts, and in a market-centric payment system, or even in the more modern artist-centric payment system of Deezer, you can possibly make money out of it by streaming massively the content you provided to the DSP with those accounts. So I told you this guy was bad. Okay. Oh, come on. Where am I? Okay. So we are very committed in Deezer to fight fraud, and we will want to make like a very fair platform for the artists. So we are very concerned about fraud, and so fraud is not only AI music generation, but it could be part of it. Okay, so I told you that you could generate now massively content with a single click. And here, this shows the average number of tracks delivered to Deezer per week. Among, yeah, there is someone talking to you, by the way. Anyway, so you can see the number of tracks that were delivered weekly to Deezer from 2009. So 2009, you can see it's about 10 or 20,000 songs a week, and you can see that it's raising that like hell, and we are having like a lot of track delivered. So it's not all AI generated content, but part of it is definitely could explain it. Okay. So what other, so maybe from a more right owner perspective, what other problem does it generate? Copyright infringement. So generative models are based on machine learning. Machine learning means that you need data to train your model, to feed your model, and data can be possibly copyrighted and not licensed for training a machine learning model. So you may say, well, music composition has always been based on inspiration, so why do we care? The AI does the same thing, inspire from other work and generate new music. I would say that major labels disagree with this, so you're probably aware that all major labels sued Audio and Suno recently. And I guess we can kind of agree with them that there may be some copyright infringement here. So this song was actually generated by Audio. No, it's not Mariah Carey, it's Audio. Okay, so you got the point? Hey. I'm sure it will play again. No, okay, that's good. So you get the point. this is a total rip-off of Mariah Carey. So it means first that the model was trained with this song, definitely, because it didn't invent it out of nothing. And something else it means is that those models may generate contents that are clear copyright infringement. Stop it, please. Okay. Okay, so maybe a brief recap of all the problems that the threats that AI music generation poses on the whole musical industry. So first, possible dilution of artists and labels' incomes, so possibly with fraud, but more generally with unfair competition with automatic systems. Violation of personal rights, so I didn't talk about it, but maybe Michael Jackson was not very, would not agree that we use his voice for singing the Get Lucky song by Daft Punk. Possibly copyright infringement, so I just show an example of both the problem. For Deezer, catalog flooding with massive delivery. Possibly editorial and recommendation problems, user deception, because you can be exposed to content without knowing, and the artistic relevance may be, when it's not copyright infringement, may be questionable. Okay, so what should we do? And this will be so the main part of my talk. So we think at Deezer that AI music generation is not a problem per se. So I just talked about Suno, Udio, and vocal cloning, but there are tons of other tools which are a great opportunity for creators. But there is a need for transparency, and we need to know when a song was generated, when possibly there are risk of copyright infringement. So we need tools to identify generated content, clone vocals, to monitor large catalogs, and to detect possibly copyright infringement. So I will talk a bit about some work we have been doing with Deezer. So those are research work. So you will see that there are other people working on those topics. But in the academic literature, there is actually very, very few work. So there is a lot of work on trying to detect generated text, so ChatGPT generated text, generated image, so generated by Midjourney, by DALL-E, etc. But there is also for speech, there is a lot of work trying to detect deepfake for vocals, but there is almost no work, no academic work, no published work on trying to detect generated music content for music. So I just will warn you that this focuses on audio generative models such as Suno, Udio, or Refusion, so like generative models that will be prompt-based and will generate a whole waveform. There are a ton of other ways to generate music with AI, but I won't talk about it in this talk. So basically what we'd like to have is to monitor some generative models such as Suno, Udio, Refusion, and some other, and to so adapt a machine learning model that will take an input file, an input audio music file, and that will do two tasks. The first one is telling, okay, it's generated or it's not generated, like it's authentic music or it's generated music. And another thing is predict the model. So it was, for instance, generated by Suno or by Udio. So why will you need to predict the model? So as I told you, Suno and Udio got sued by major labels. So it may happen so that they get sentenced. So it may happen that we have to remove the whole catalog of Suno delivered song, Udio delivered song to Deezer, and we need a way then to detect it and to know what model was used for generating the content. Okay, so I will talk about this first work, which is detecting audio that was generated by generative models such as Suno, Udio. So this is actually a research paper that is already public and that you can read, which is called Detecting Music Deepfakes is Easy but Actually Hard. So what we did is that we trained a machine learning model for detecting both whether it was generated or not, and the model. And we evaluated it in a very controlled setting to have insight about the functioning of the model and understand how it works and what it's capable of. So we used the dataset of copyright-free music. We did a lot of stuff that I won't talk about, like avoiding semantic content confounders. We may talk about it later. We actually tested 9 artificial models, actually 3 or 4 different classes of models with different parameters. And we so trained this detector, this machine learning-based detector, to discriminate real from synthetic music based on very basic properties of generative models, which are the in the generated content, there remain some artifacts that sometimes are a bit audible, sometimes not, and that are very characteristic, that are statistical characteristic of generated content, and that allows to discriminate them from real content. So we trained this model, and we got a quite high accuracy, 99.8%, which is high, don't you think? Yeah, and with quite a small model, actually. So, okay, so now we may say, oh, the problem is solved. We have a 99.8% accuracy. And yeah, other people also have been claiming very high accuracy like that. But did we? So as I said, 99.8%. Hey, fantastic. So what could happen? Let's imagine that there are a new company called Studio that will release a new model, Studio.ru, based in Russia. They don't really care about copyright infringement then, just saying. And they release a new model, okay. Or Udio release a new version of their model. And what will happen with the AI detector is that, oh, shit, the accuracy dropped to 0%. So that's really bad. So what happened? So here we see on the left side, we have the model the detector was trained on. So you can see that there are actually 4 categories of model with different parameters. You have this encodec, so I won't give detail about them. And what you can see is that if you train on a family of model, the detector is very good at detecting the family of model, but the accuracy on other models drop to 0. So the models are very specific to the generative model it was trained on, which means if there is a new model, you won't be able to detect it, and it's a real problem for DSP because models get released every day, and we need to be able to detect those new models. So another problem is that you can possibly attempt to attack the AI detection model. So how will you do? So let's imagine that at Deezer we have an AI detection model. So someone used to know, yeah, someone with a black hoodie, you know, will generate some song. He will deliver it to Deezer. We then apply this AI detection system and say, oh, it's AI generated. Oh, it was generated by Suno, and Suno got sentenced. So hey, we remove it. Okay. So this black hoodie guy will say, okay, I really want my content to make it to Deezer. So I will try something. I will alter slightly the audio content such that it fools the AI detection system. So attacks can be very simple: speed changes, time stretching, pitch shifting, equalization, adding noise. And you have the result of this here. And what happens is that for some particular very simple attacks, such as pitch shifting, you will have a huge drop for several models, so for encodec and for DAC, for instance, of performance. So it's very easy to fool the model. So it makes it very easy for fraudster or bad actors to just discard the model. So the main idea here is to say, okay, It's not solved. There is a lot of work to do to have like robust tools, and yeah, and when you hear like very high accuracy number, just check what it means and what is the context of this number. Okay, some other work we've been working on. So it was like based on audio only. We have also written a paper about detecting AI-generated lyrics from text. So, for instance, yeah, very simple. You have the authentic lyrics on one way. You generate some lyrics with ChatGPT, and you have the system which will say whether it's authentic or synthetic. So in a real setup, what you will need probably, because you won't have the lyrics delivered to you, you will probably need so here, yeah, that's the generating process of Suno, where you can actually customize your lyrics, or you can use a generative model, which behind the scene will generate lyrics. So obviously you get delivered the audio, so possibly what you could do is do some transcription with possible error of transcription. So you go back to the text from the audio and then apply your detection system. So we haven't tested it so far. So far we have worked only on text, and we have quite positive results at the moment with good generalization property, because we work on very different aspects. Like for audio, we are artifact-based. Here it's more content-based, so it generalizes quite well with many languages, artists and genre. But yeah, it's not solved either. We haven't tested on transcribed data, so like the real setup that will happen. And possibly we have used generative models that was not designed specifically for lyric generation, which means there may be obvious cues of lyrics generation. For instance, that the verse is not exactly the same and has a strong variation, and it's a very good indicator that it was not generated by it was generated by an AI. Okay. I talked about AI-generated content detection, and I will also finish my talk with this other problem. So I talked about vocal cloning. So for instance, you have this vocal clone voice of Michael Jackson on top of Get Lucky. And when you got delivered that in Deezer, what you want to be able to identify is whether it was a clone vocal or not. I won't talk about this problem here. And also, you want to detect the artist that the vocal is a clone of. So basically, how does it work? A very technical slide. Probably the two next slides are the most technical. Basically, what you will do is like you will select the artist you want to monitor. You will select tracks from those artists. You will do possibly vocal isolation, so removing the vocal and removing the mix and just keep the vocal. So the problem with that is that it's quite computationally costly, so we'd like to get rid of it, but as you will see, it's not that easy at the moment. And then you project that in a vector space, so every track become like a small dot in this 3D representation. Usually we use much more than 3 dimension, but that's just for illustration. And this embedding function is actually parametric. Usually it's a neural network, and we will optimize it in the following way using what is called contrastive learning, and we'll gather points corresponding to tracks of artists together. So once you have this space, if you got a new track, so possibly the new track arrives around here. So you say, okay, I have a track here. It's very close to those other tracks, so it's probably Dalida. And you can then identify what artist it was based on. So we did that. We did that first on authentic, not generated data, so not cloned data. And here you have like the accuracy we get for several number of artists. So if we monitor 100 artists, so we have a list of 100 artists, and we ask the model to predict among those 100 artists which one is it. And so we got about 90% of accuracy. And if we raise the number of classes, obviously it will decrease because the problem gets harder and harder. We get state-of-the-art performances on that, and we did it on mixes, which was kind of the first time, because most work will work on a cappella. And about that, actually, what we did is pre-step of source separation, vocal isolation. And as you can see, like it's the green dot here, and you can see there is a performance gap using source separation. So still, we need source separation for having a great performance, which is kind of a problem for productionalizing it at the moment. So this was on actual data. Here, it's on another data set, which is only AI-generated vocals, so only cloned vocals. And as you can see, the performance dropped quite much. So it means that possibly it's more difficult. Possibly also some of the models we tested were not that good, so we were not that good at identifying the original artist, but maybe it's just because it's not that similar to the original artist. And what you can see is that the gap with the source separation processing is also getting bigger and bigger. Okay. Very, very short summary of what I wanted to say. AI-generated detection and related task about voice cloning is hard and is not solved. So when someone announces an accuracy of 99 dot whatever %, double check what it means, because it only means something in the context of the evaluation they did, and possibly there are drawbacks that you don't see on in these figures that make possibly the system useless in some application. Okay, so what are the remaining challenges I'm talking about? So generalization, robustness, I already talked about that. Actually identifying artists in an open set setting, so not possibly testing it on an artist that was not monitored, is actually quite tricky still at the moment. Also, so I talked about audio that was generated from scratch, but possibly, and this is something that happens a lot, you may have some stems that are real and authentic, and some other stems that will be AI generated. So something that will happen a lot on possibly a rap song with someone actually singing on a generated instrumental